Hey guys, in this video we are going to talk about how to find and apply conditional probabilities. But first we need to know what conditional probability is. Conditional probability is the probability of an event happening given that another event has already occurred. So the event A, the probability of that happening, is conditional on event B having already happened. So we use this notation here. You'll notice we have that vertical line. We read this as the probability of event B given that event A has happened. So that vertical line means given that. If you see this in other contexts, sometimes it can mean given that, sometimes it'll also mean such that. It says the same thing mathematically. And so remember, we have our formula here now. This P of A and B, remember that word and means we're going to take the probability of A times the probability of B all over then the probability of event A. All right, so let's dive into some examples. We have Clint. Clint drew a card from a standard deck of playing cards, so 52 cards. What is the probability that he drew a queen given that the card was red? So the probability that he drew a queen given that it was red. So we're going to have the probability that it was red and a queen divided by the probability that it was red. So probability of red and a queen means we're going to have 26 out of 52 cards that are red, so that represents this part right here, the probability that it's red, times the probability that it's a queen. Well, there are 4 queens out of 52 cards. Divided by the probability that it's red. Well, the probability that it's red is 26 out of 52. So what you'll hopefully notice is that you have 26 50-seconds divided by 26 50-seconds. So while this looks scary and intimidating, that fraction just cancels out. So we have 4 over 52, which does simplify. And we end up with the probability that's a queen, given that it's red, is 1 out of 13. All right, let's try one more. We have a number from 1 to 100 is randomly selected. What is the probability that is a perfect square, given that it is an odd number? Well, let's think about our perfect squares from 1 to 100. We have 1 squared is 1, 2 squared is 4, 3 squared is 9. Then we have 16 for 4 squared, 25 for 5 squared, 36, 49, 64, 81, and 100. All right, perfect. So now when we think about the probability that that number is a perfect square, I'm just going to write SQ for square. Given that it's odd, means if I use my formula, I'll have the probability of it being odd and a perfect square divided by the probability of it being odd, which again, this word and means I'm going to find the probability that it's an odd number between 1 and 100. So the probability of an odd number between 1 and 100 would be 50 out of 100 because that 1 and the 100 are included, and there are going to be 50 odd numbers, half of them. And means times. Perfect squares, well, if I go through and count, I have 10 perfect squares, so 10 perfect squares out of 100. And then I'm going to take and I'm going to divide by the probability of it being odd, which is 50 out of 100. And then again, you'll notice that same thing happens. You have 50 over 100 divided by 50 over 100. So those cancel. And then 10 over 100 does simplify. So the probability that it's a perfect square, given that it's odd, ends up being 1/10. All right, perfect, guys. Check out the next video when we talk about conditional probability and two-way frequency tables. All right, till next time.